Thank you for having us and introducing me. This is Seongyong Kim. Can you see my screen?
Yes.
Yeah. This is Seong Kim from the Georgia Tech. On behalf of our research team, I will present this paper titled "A Framework Reconstructing the Piping System on Class-imbalanced 3D Point Cloud from the construction side." Basically, this is collaborative study between the Georgia Tech and the Hanyang University. I'm working at the robotics and construction automation lab. So here is the content. First of all, I go through the background on the 3D piping system in the construction site and the research problem that we have focused on, related work, and our proposed method of reconstructing the piping system, starting from the data preprocessing, the semantic segmentation, and the pipe reconstruction. And then I wrap up the presentation with the evaluation and the conclusion section. So here is the background. The mechanical and electrical and plumbing industry, or the construction, the architecture field, can make up a large benefit using a 3D model, especially for the 3D piping system. So, and this figure shows how we can capture reality into the 3D models. First, using a LiDAR scanner, the point cloud, which only include the low-level physical information, physical shape, is collected. Then we can convert this data into the vector or the solid object model. So by doing so, we can reconstruct it as model of the site. And given with this kind of as-is 3D model, we can perform a geometric inspections or the maintenance or the construction pace monitoring. So there is increasing demand to reconstruct the as-is piping system using a 3D point cloud. So, however, the point cloud collected at the construction site we have a difficulty in applying an existing 3D reconstruction method because the data collected naturally includes some of the noises or the occlusion area and have some class imbalanced issues. So we propose the framework to reconstruct the piping system to overcome this problem. So there are a lot of the application of the 3D model in the construction field. So, but many of these studies currently highly depends on their on-site condition. So, for example, they usually tended to applying a parametric method, requiring the hyperparameters related to the site conditions, such as piping radius or that kinds of information. But recently, with the advance of the computer science technique, the researchers is increasingly using a data-driven model, such as the 3D deep learning segmentation model. So 3D semantic segmentation, which assigning a class label to each 3D point. So for these studies, we utilize the PointNet, a very famous and representative the 3D segmentation deep learning model, considering a future expansions. So, and about the imbalanced classification, referred to a situation where some classes have a remarkably higher version than other classes, which is a very common situation, user situation in the construction site. So what I'm saying is that most portion of the classes in the collected at the construction site is included in the structural objects such as the wall or ceiling or floor, and piping system has a very minor portion, so which caused the problem. So for this study, we are using a classifier level of the method, like adjusting a threshold or adjusting a weight based on the portion of the class volume. So here is the proposed method, consists of the 3 parts. the first three 3D data preprocessing, and then the semantic segmentation and the pipe reconstruction. So for the preprocessing, we denote the 3D point cloud because there are a lot of the meaningless point there. So we apply the statistical outlier remover, then adjusting rotation of the data. So the purpose of this translation is to align our 3D point data set to fit the perpendicular and the parallel as much as possible to the X, Y, Z axis. And the sampling means that we use the sampled point because of the computational limitation. So here this part is the preprocessing, and then we apply the semantic segmentations. So this is the deep learning part. We adopt the point net as a backbone network. So we input the 3D point cloud as it is directly, then the output of the network would be the point with the assigned the class label. So PointNet is known as the point scaling transformation invariant model. So that's the reason we used it. And for the evaluation studies, we additionally apply the point normal vector or the LiDAR intensity. So we can see the result in the future slide. And regarding the class imbalance issue, we apply the weight and the threshold method. So lastly, after segmenting, extracting the point, piping point, then we reconstruct the piping system. So we apply the efficient RANSAC algorithms for detecting the cylinder shape primitive. So this figure shows the result. The red dot means the point cloud detected as the pipe class, and this green cylinder is the reconstructed piping system. So about the data set, we collected the data set ourselves. We collect at the indoor construction site using a Federal Rider scanner. So total 4 scans were used, and then we manually labeled our data set into the 10 classes, such as the setting, column floor, of course, the pipeline. So about the deep learning training, the environment setup is this number. We use the sampling point number of the 1024, and flex block size is the 2 meters. Yeah, and for the evaluations, so as we only use the 4 scan of the data set, we use the cross validations. So here is some result of the segmentations. So the figure on the left is the ground truth, so which is we manually labeled. So, and the right one is the prediction. So as you can see that there are some misclassification on the ambiguous point, but overall, the majority of the point is well collected, well classified with the construction object. Yeah, here is the evaluation table and our evaluation studies. So starting from the basic point net, we added our proposed added additional conditions to our preconditions. So we can see that after applying all the rotation or the LiDAR intensity or normal vector, we can get almost 89% accuracy in the piping system. So regarding the class imbalance issue, we additionally apply the threshold or the weight method. Yeah. And here is the evaluation for the pipe reconstructions. So we know that it highly depends on the result from the above sections, but we can get sufficient accuracy. So, and here is the conclusion for our study. We propose the framework to reconstruct the piping systems with the class, relieving the issue of the class imbalance situations. And as a future study, we will extend and generalize the current framework, the algorithm, to get a more robust performance in the construction site. Yeah. Thank you for your attention. And here is my contact information. And do you have any question or any comments?
Thank you.
Please.
Thank you. Thank you.